All right, so these are the challenging concepts for Module 10. I'm just going to go over three concepts that I came up with. We're going to hop into Visual Studio, and I'll just show you exactly what those challenges were. The three challenges were the responsive design implementation, the skeleton loader, and then also the pagination that we implemented on the content manager and user manager pages. So on the responsive design implementation, um, the challenge was to make the screens look functional on the different screen sizes. So we used the MDN documentation for the standard to define the breakpoints. Um, Small mobile devices at 320 pixels to large screens at 1200. Um, One of the biggest challenges was switching the sidebar from being a left sidebar and fixed for desktop to a hamburger menu for the mobile. And then conditional component rendering, breaking off at 768 pixels, and then also having a consistent styling across the breakpoints. So ultimately, what we did, we designed a system using a mobile first architecture, as I said, with MDM web development best practices. So we set the breakpoints at 768, which is iPad portrait size, and serves as the key dividing line between the mobile and the desktop. So 320 pixels was extra small, 480 pixels was small, and 768 medium to 1024 large to 1200 extra large. So we used the at media query to change the styles using CSS as opposed to JavaScript to manage the breakpoints. And then the main thing was hitting the layout .jsx file, which I provided all the requirements in the responsive design AI feature document here, and I specified exactly what I wanted to have happen. Um, and in the scope, the nav bar, uh, the breakpoints, touch friendly navigation and heading, and then also what was out of scope. So when I provided this to AI, it built it, but it still has some um, issues as far as rendering. So that was the main challenge, was doing the page components and CSS implementation on the different pages. So once we got the navigation menu fixed, that problem fixed with the hamburger menu, we created a whole separate file for that, the mobile navigation.jsx file. Um, and that renders when the application is on a mobile device. Then we had to go in and change the colors, some of the padding, and the font size here. So we had global things that we did across the site, and then some things that were just um, relevant to specific pages. But ultimately, we created a styles variable for desktop, and we set the padding, the font size, and flex direction there. And then again, so we use pure CSS queries instead of JavaScript, and created the use effect event listeners um, that helped with knowing what size the application was at. And the outcome was seamless user experience across all device sizes, no horizontal scrolling on any viewport, touch friendly interactive elements, improved accessibility with proper focus states, and reduced the bounce rate on mobile devices. So, all these things were done by using the web standard practice from MDN, referencing that, creating the right specification doc for AI to get started, and then actually going in and providing key elements on making sure the padding was correct, that the font sizes were correct, and that there were scroll features on the mobile devices, as you saw in the other video. The second challenge was the skeleton loader implementation. So the challenge, users experience a jarring experience when data was fetched from the server side page that would show empty spaces or a blank screen, making the application feel slow and unresponsive. And ultimately, what this was, when information is being fetched from the database, there's a small period of time where the screen kind of looks blank and may cause the user to leave. So that's what we define as the poor perceived performance. The user is going to perceive that the app is slow due to the blank loading states rather than content awareness. So when we implemented the skeleton loader component, we used the skeleton loader JSX, and then we have the different types, um, default posts, and it determines the skeleton layout style. So we had card, we had post, and then we had user. And then also the number of skeleton placeholders to render. At default, it was just 10, which was what we have as a base for the posts when they come up on, especially on the user manager page. So the post skeleton is used by the blogs, home, content manager pages. Gave a 2-column layout matching the blog post structure. Left column avatar, name, date, and right column 3 lines of text, placeholder, and action buttons. So it matches the blog.jsx layout exactly. And then the card skeleton, the individual card in the responsive grid was used for the admin and network pages, which use cards in their design. And the components were the avatar, name, role, biography, placeholder lines, and action button. Scales with the grid layout automatically, and use with count 2 in admin and count 6 in network. So there's only 2 cards, on the admin page, and then we just use 6, even though there may be more on the admin page because the viewers can only see about 6 at a time. So what happened there was when the user loads that page, it halts for just a second and then brings it up. And then we have the user skeleton used by the user manager and the user update pages. So those are tables. So it gave the table row format with multiple columns, designed for administrative interfaces and a dynamic count. And then we use the base style and light gray backgrounds with rounded corners, pulse animation, so that it fades between 1 and every half a second, every 2 seconds. And then also keyframes. So basically, it's just an animation that fills into place while the page is being loaded to the API route. And these are the pages that we use here. Again, blogs, home, admin, network, content manager, and user manager. And this gives the post type. And so the eventual outcome here was an improved application responsiveness, reduced perceived load times by 40%, eliminated cumulative layout shift issues, consistent loading experience across all pages. And what it did, it gave it a professional modern UX pattern adoption. So, it gives it a more modern feel and experience. And then challenge number 3 was the pagination system. So we used 2 pagination systems on the user manager page and the content manager page to display the agents and the post. The challenge there was, managing large database in an admin heavy application required efficient data display without overwhelming the server or user experience. So the server load management is fetching a lot of records at once, and one post could take a lot of time. So by adding the pagination system, we're able to get a small amount, a little bit of time, enough to get the user started. And then we also have dual architecture requirements. So we got server side for user and client side for post. and then filter the context, maintaining search filter parameters while navigating the pages, state complexity, managing multiple interdependent state variables such as current page, items per page, total count, and filter without bugs, and then the boundary conditions. So we completed two complementary pagination approaches and tailored to each use case. Number one, the server side pagination on the user management page. So we had the state management, which was current page, and that loads the current page being viewed, items per page, set the default to 10, total users, and that was the total count of matching users from the server side response. And here's the parameters here: page, limit, first name, and last name. So the workflow, it fetches the users from the API, constructs a query with the page, and then is at the backend endpoint, receives the parameters via the query string. So ultimately, this operates in the back end and posts to the front end, and then we're able to use UI controls here: previous button, next button, number buttons, and the page size selector. How many items per page we want for each pagination style, and then we also have the filter behavior here: first name, last name, and again, it's triggered by the use effect hook. And then these are supporting components that we have with that. The user update. So when the user updates their profile, and then we have the confirmation modal for delete and update user. And here are the routes to the back end. We have user.routes.js, and those are the route definitions, user controller, and this is where the pagination logic is exported. And then we have the schema to get the data validation, and then also the connection to MongoDB. And then for the second, on the content page manager, it's very similar, but just a little bit different. We updated the user limit because here we're doing posts instead of actual users. So it fetches all the posts in a single request and all the users. And then we got the filtering on the client side for start date and end date using the calendar there. And then the pagination indices are calculated with the items per page and the slices array here. So the pagination calculation is held in the variable skip, and then how many posts, and then the total pages. And it rounds it up so that there is an even number of pages. And then we have, again, for the UI controls, we have the previous button, the next button, and the supporting components: avatar initial, skeleton loader, and delete confirmation modal, because you can actually delete the post there. So they just want to ensure, we just wanted to ensure that the user was sure that they wanted to do that. And the outcome here was, just an efficiency of loading large page, handling large user data sets with server strain, fast filtering, pagination, consistent state management, proper handling of boundary conditions, and improved admin efficiencies, as well as reduced API calls and bandwidth storage. So that concludes the challenges that I faced there. This file is also going to be held in our docs here folder and the Codeboxx project. So that concludes the challenges that we faced here. I just want to thank you for your time, and we'll see you in the next module.